Yeah, these are all uploaded on YouTube, and this one will be recorded as well. So by the way, can you guys answer this poll about which is the hardest topic? Because we'll spend the most time on that then. I will start at 3:30, so in 3 minutes. To allow other people to join. I got 4, but that's because I had like 2 exams that day, so kind of unlucky that day. Okay, so I guess I'll start now because it looks like no one else is joining. So, welcome. This is the AP CSA Unit 2 review, hosted by me. And about Five Hive, this intro session was prepared by me as part of Five Hive. It's led by Lance. Five Hive is a volunteer student-run initiative with 100 plus volunteers and 10,000 plus combined volunteer hours. Considering checking out fivehive.org for more resources, and as this month and the year goes on, there'll be more articles uploaded. As you've seen, Unit 4 has recently been in the process of being published on the website, and next Unit 1 will also be published. And Unit 2 is already published. If you'd like to contribute to Five Hive by helping with website development, hosting lectures like these, creating materials, or helping with outreach or helping with creating survey and FAQ documents, please check out this document for more information. And I will link the document right now. And there's 2 forms. The first is the application, and second is the feedback form, which it would be greatly appreciated if you fill out before you leave. And applications are reviewed on a rolling basis. And here's your Insta, TikTok, there's a YouTube, and there's Discord and the website. So, unless there's any Unit 2 specific questions that you guys have, we'll just be reviewing like the articles that MGA made recently and doing all the practice questions and tracing the code for those because that looks like the winning topic, the winning part of Unit 2. So unless you guys have any questions to start with, it'll just be a walkthrough of the articles. And if you're unable to watch the entire thing, it'll be published on 5hive.org on YouTube. So Q&A, we'll start with Q&A first. So any questions? What is the exam like? Okay, so the exam pretty much is you go into the exam room and you first log in the blue book and all that stuff, and you start with the MCQs, which they did change a little bit. So now I think it's 42 MCQs with 4 answer choices. And pretty much you have to work through those MCQs and trace. Oh, you can. So the exam starts with MCQs. Okay, and okay. Nice. So for the MCQ portion, it's 40 MCQs, and pretty much you have to trace them. A lot of them involve tracing. And the second part is 4 FRQs, and the first one's usually on methods, the second one is on class design, third one is on arrays, and fourth one is on array lists. Or, yeah, it's on array lists. And pretty much you have 90 minutes to work on both sections. So is that answer the question about what the exam is like? Alright, nice. And by the way, I can't let you guys on the stage. It's like against the server. Will we see exam-like questions? Yeah, MJ made some pretty good questions. So if we have no other questions, we'll just start walking through the topics one by one. But we'll first allow for question time. So, going once, going twice. Alright, so let's start with the article walkthrough. So the first topic of this unit is 2.1, which pretty much is about, it's like an introduction to the entire unit, which is just pretty much algorithms with selection and repetition. And so an algorithm has 3 parts, which are selection, repetition, and sequencing. Selection pretty much is your if statements or your Boolean expressions. Pretty much, is it true or false? So, try this question. Can you have an algorithm that is void of selection, or that means it doesn't have selection? I'll make a poll for that real quick. Uh, is it true or false? This first question. Okay, the winning answer is true, so we'll choose true. Which is true, which is right. Because you must have all 3 of these, and without them, it's not an algorithm. Because as we stated here, algorithms must have all 3 of these parts. Alright, repetition pretty much is when you have a loop. So pretty much your for or while loops that we've learned so far. It's pretty much your for and while loops. And this is the most that you'll see in the AP exam. You'll see a lot of just for a variable going through some class or some data set, which you'll see in arrays and array lists. And you'll just keep seeing, it'll just keep going through, and you just have to go like, the first variable is x, it starts at 0. It goes through the loop, now it's 1. You do it again, now maybe it's 3. Because if it's like x is greater than 1, it does something special. And you just keep doing that again and again. And the final part is sequencing. And this is the most abstract. And it pretty much refers to the order of this thing. So as we said before, we have a for loop, we have a while loop. So if you do a while loop first and then a for loop, there's a difference. So that's like sequencing. And if you have if statements in between, it depends on the order of it, which makes what sequencing is about. So we'll try these few practice problems. Let's zoom out. Alright, so I'll create that poll. So choose the best answer that you think makes sense for this question. Okay, and this is for the next question, but so the winning answer for this one is D. Okay, and what about this one? Oh, this is just true or false. Just use A and B for this one. A is true, B is false. Okay, we got one vote. Do all algorithms have sequencing? Okay, looks like it's true. Okay, let's check. And both those are right. So, any questions about this first one? About why it's 1 and 2? And why this has selection, because there's an if statement, and sequencing, because if there's no mold. And it has multiple steps. There's if and then otherwise, and there's an if in the F. An if contained in an if and else statement. And there's no iteration because there is no like for loop or while loop, like saying do this multiple times. For this one, it's true because as we said, it needs all three stuff. Next topic is 2.2, which is Boolean expressions. And Boolean expressions are statements that go to true or false. And we have a few operations, which is equals equals to check if two values are equal to each other. Not equals, which is the opposite of that. Will CSA have office hours? Yeah, tomorrow there's office hours for pre-calc and CSA combined. And this is sort of like office hours. It's like a mix of both. And there's comparative, which is just your greater than, less than or equal to, or greater than or equal to. And these only work for numerical values, or your ints and doubles, or your floats and stuff. But for AP exam, it's just ints and doubles. So let's try this practice problem. For if I is 9 and j is 10, and you do some operations, is I greater than or equal to j? So I would recommend tracing this out. I recommend tracing this out. Can you remove the red? Yeah, sure. There. Okay, we got 3 votes, so I think that's everyone. So let's check the answer, which said true, and that's true because if you trace it, you would start at I is equal to 9, it would become I is equal to 7, j would start at 10, it would become 4, you would subtract 3 more, I would be 4, and they're equal to each other, so that is true because it's greater than or equal. Alright, so now we're gonna move on more on the operators, the equality operators. Are these true? Again. And I'll put poll for that. Yeah, if it was just greater than, it would be false. Yeah. Okay, we're split, so there's one more person has to go, so we'll wait on that. False is the one winning, so we'll check false. It's true because these are numerical values and it's saying they're equal to each other. So we're checking if 3 equals 3, which is true. Yeah. Equals is comparison. This would only be false if you start involving classes, but for int values, they're equivalent. You're thinking of classes? Okay, then here's your classes. Speaking of classes, we have classes now. Okay, we got 2 votes, and they're both false, so that's the majority, so false, and that's true. And it's false, so which is correct. And it's false because you can only comparing objects is different than comparing primitive values like ints and doubles. So now we're gonna look at this. So let's pretend we have 2 boxes. We have the box, and for primitive values, the box will simply store the value as what? So let's just say the box is called bro, and this box holds the int value. For object variables, they like to be different. And instead of storing, they store it at memory addresses. So, for example, we have a box. It stores it at this address, but it stores the same content at a different address. So pretty much it's like different addresses. And when you're using equals equals or greater than or equals, you're actually comparing the values stored at those box. You're just comparing the addresses, not the actual contents. And that's why you shouldn't use equals equals for box for classes, and instead you should use dot equals, which we'll focus on later. Alright, so let's try this question. This is like a more complex version of the question we did before. Yeah. So I'd recommend chasing this out and trying it out. And remember, for the AP exam, you do get a piece of paper, so, and you can ask for more if you need it. So I would recommend asking for as much as you need to trace your code out. Can you put a picture in here? Yeah, sure. So for this, okay, my thing is still broken. Oh, there, fixed. Nice. So if we go through this step by step, we would see this starts at 89. We would say var2 would be 89 minus 62, which would be 27. And now we're subtracting var1 with 64, which would become 25. And we're saying var3 is equal to var1 plus 18. So var1 is now 25, so plus 18 would be 43. And then from there, we start comparing. Our first comparison is system.out.println is var1 equal to var2. var1 at this point, so let's just do 1, is equal to 25. 2 is equal to 27. And 3 is equal to 43. So is var1 equal to var2? Nope, so this is false. So that eliminates B and D. Our next thing is says that var1 plus equals 2. So now this is going to be 27. And now we're checking if var1 is less than or equal to var2. But now they're equal, so that means they're true. And now we're checking if var2 does not equal var3, which is also true. And finally, we have a more complex compounded one. So it says var2 times 2, which would be 54. And var3 plus 12 would be 55. And this would be false, so it would be C. Does that make sense for everyone here? Yeah, okay, nice. And that's how you trace pretty much. You just go line by line and you go and add code. Does that make sense for Gymnast 78 and J? So, fine. If there's no questions, so this is C. Let's now try this one with the same idea of tracing line by line. And I'll put the screenshot in the chat again. And 1 sec. And the question. Hello, Supra 4186. We're currently on 2.2, which is Boolean expressions. And we so far just went over 2.1. Okay, we got two answers. So we'll trace this once again. So we have foo is equal to 17 and bar is equal to 14. So our first statement is plus equals 3, which means now bar is equal to 17 because we first added 3 and then we set equal to its new value. And now we're doing bar minus equals 1. So now we're subtracting 1 and then setting it to itself. So now this would become 16. So is bar 16? Oh, wait, oops. Is foo 17 less than bar 16? True or false? False. Oopsies, I reload the page. That's fine. Becomes 17, 16, 17, 16. This would be false. Next, we're saying bar is less minus equals 2. So now we're going to subtract 2 from bar. Means it becomes 14 again. And now we're saying 14 does not equal foo. Is that true or false? True. Okay. And then we're going to finally check if 14 is less than or equal to 17. Is that true or false? True. Which means it would be A. And we said this one was C. We got both of them right. All right, next article. Next article is 2.3, or your if statements. And if statements are pretty much just saying, you do this, then you do this, then you do this, then you do this. But if you have an if statement, you're saying you do this, then you do this, but then if this is true, you do this thing. If it's false, you do the other thing. And the simplest form of this is if condition, so you put your Boolean expression in here, then do something else. And so let's try that. Here's another example, and you're just trying to find out what this program outputs. And I will send a screenshot of this because I shall zoom out again, I guess. But so I recommend tracing this again, but now you just have if statements, which is just the same thing we're doing before, but now if it's true, you do it. If not, you just skip over that section. Okay, we have one answer. Give like another minute for this question. And we got both as B, so we'll check our answer. And it's true. I still don't go over it because we both got that, so. Look at the next one, which is just if-else statements. So now an if-else statement, the difference is, if something is not true, then you're gonna do this. So pretty much if A is false, and if this is A and this is B, if A is equal to false, then B will be automatically run. And if A is true, so that means this runs, this will never run. And that's pretty much it for that. So now that you know the true false and what an if-else statement is, we're going to do a full question. Which this is a pretty long one because it covers an entire the full class. So, okay, I guess I have to send this in screenshots because this is too long. Alright, so you're looking for the output of this program. So I'm gonna put the question first. And then here's the method. So that's your question. It's the first one. So I'll make one sec. And hello for the few new people who joined. This is like we're on 2.4, which is like the if and if else statements. So I recommend you try tracing this out for the new person who joined. So percent sign means mod pretty much. And mod pretty much means you're doing the remainder of it. So for example, if we do, sorry, if we do 5 mod 2, right? It would be 1, because it would be 5 divided by 2, which would be 2.5, and this would be like a remainder of 1. No problem. I see you also love that, like that emote or emoji. And here is the daily reminder, or like 30-minute reminder. Before you leave, please fill out the lecture feedback forms. So next lecture will be even better. So we have an answer, which was B. So let's check. We'll trace through it, I guess. So we have a method. And oh wait, someone's typing a little bit. Wait. You'll skip this one? Okay. So it starts with a method and you pass in two numbers. When does this lecture end? It's gonna end around 5:30 EST, so around like 90 minutes is like the plan. But if we finish the articles earlier, it'll be done earlier. So we have a method which passes in two numbers, which is 1 and 2. And then from there, we have mystery method 1, which takes in our first number, which will be called 1, and then it adds one number to it, and it checks if it's divisible by 2 or if the number is even. If it's even, it prints it out. If not, it prints out its remainder. And at the end, it looks at number 2 and it prints out if it's even or not. So we'll check. It says mystery uno is equal to new mystery 67319. So we'll first plug it in. So now this is 67 and this is 319. So we'll go through it. First, x is going to be equal to 67. Now this is 68. This is true. So it's going to print 1, which would be our method that we defined it as. So this is going to print 6, 7. And then else is going to, it's not going to do the else, so it's going to skip this. And it's going to go here, and it's going to check if this is even or not. And that's false. Because 319 is not even. So this will be false. So we see it prints 67 and false, which should be C. Does that make sense for you? Okay, I'm gonna guess it makes sense because you're not asking a question. So we'll try this one now, which is a little bit longer one. It's just if and else statements. There's no methods anymore. That works. Here's the question. And now you can just spoil your answers. Actually, hold up. I'll create a poll. Be consistent. Oh, this is supposed to be 2.4. Oopsies. It's fine. Okay. So if you got a paper near you, I can go over it then. So we'll zoom in real quick. So it says bar is 14 and foo is 17. So 14 is greater than 17. And we rewrite that. So it's not bad. 14 is greater than 17, which should be false. So we're gonna skip this step and we're gonna go to the next step. And it says foo is minus 4. So now foo will be equal to 13. From there, we're gonna say foo, I'm gonna check bar, so that's 14 still, is less than 13 or greater than 13. And this is also false again. So we're going to do bar minus 3, which would be 11. Oh, I messed that up. That's all. No, just not in. So this would be skipped, and bar would be minus 3, which would be 11. And now we're going to compare. So it would be, we have 13 and 11. So 13 is greater than 11, which is true. Now I'm going to say bar is minus 2, so now this would be 9. 9 is not equal to 13, which is true. And 13 is greater than 9, which would be false. So it would be true, true, false. Which would be, I messed up somewhere. Hold up. Okay, hold up. I messed up somewhere. Hold up. Start from the beginning. 14, 17, that would be false. 13. We'll go 13. Then we'd say 13 is greater than 11. That would be true. Bar minus 2 would be 9. 9 is not equal to 13. That is true. And then you say 9 is this. So it will be true, true, true. I think I just messed up on my order. And if you see, we got both those right. So any questions about this one on how to go through it? Questions, we'll move on. So next is 2.4, or nested if statements. Nested if statements are pretty much just saying, if do this, or if this is not true, then check another if statement. And you can just keep adding more and more. So you can just say, if A, else if B, so on. And you can just keep going through each thing. So we'll try this practice question. Alright, so try this first question. And you said to go through them. So you would first start with solving it. So you would first plug in these two numbers, which would be 64 is greater than 33, which is true. So we're gonna be only doing this section of the code. So we would first solve this. So this would be 64. We would be only doing this section. So we're gonna do 64 minus 33, and then we're gonna set equal to skippity again. So that would be equal to 31. And then we're saying we're gonna subtract that from the original 31, so that would become 2. And then they're saying we're gonna make that a double. So we're gonna this becomes a decimal, so that's 31.0 divided by 2, which would be 15.5. And then we're setting that equal to an int, so that rounds off or floors to 15. And then we're going to pronounce 15. Unless I messed up somewhere, that should be 15. And yeah, it is. And now you can do nested if statements, which are pretty much ifs inside ifs inside ifs. And then you can put an else. And if you want a diagram, it looks like this. You start with an if it's true, you do another if statement, and you just keep going. And you can do as many as you need to answer whatever coding question you're doing. So we're gonna go and walk through this question. The two following calls are seen in the same class. Foo is equal to 7 and bar is equal to 4. Foo is equal to very skivity method bar, so it means very 4, and bar is equal to another same method with now 5. So we're gonna start with the first one, which is 4. So we're gonna start from the top, and now we know this is 4. So we'll go through it. If this is greater than or equal to 5, 4 is not, so we can skip this entire code segment until the next one. And it's not any of those, so we skip this entire section. Then we're gonna go to the next one. We're gonna check our next one. Is 4 greater than or equal to that? Nope. So we can skip this entire section as well. And then we check our else statement. So we're on our else statement. So it would be 4 times 3, which would be 12. If it's greater than 10, we do 12 divided by 2, so that would be 6. And then it'd be 9. So we know our first answer is 9. And so we know foo is equal to 9. But it says foo minus 2. So now bar will be equal to 9 minus 2, which would be 7. So now we're going to go do foo of 7 from the top. So, you know this is 9. So now we have to go find foo of 7. So we're going to start from the top again. We start with 7. We check 7 is greater than or equal to 5. It is. Now we check this would be 14. This is false, so we check our next statement. If it's greater than 10, which it is, so it would be 14 divided by 3. And do the do the flooring, this would be 4. And then 4 mod 3 would be 1 minus 1, so 0. But you're adding it to that, so it would just be 5. It would stay at 4. It would stay at 4. So bar is equal to 4. So we know it is A. And for time's sake, we're not going to do this one because it's a very similar question. So I don't know what that answer is, but oh, I got it right. But so this is A, and this is D, because if you went and traced it, you'd see it would be a very similar idea. So we're going to move on to 2.5 now, which is compound Boolean expressions. And we're gonna use our Boolean expressions from before, but now we're gonna add some stuff, which is not, and or. Not is very simpler. It pretty much just flips the thing. So if it's true, it becomes false. If it's false, it becomes true. And next we have or, which pretty much just says if A or B is true, then it's true. But if both of them are false, if both of these are false, then the value is false. So if at least one is true, then it's true. For and, it's if both of them are true. So if it's A and B. And order of operations. And order of operations, it can get very complex pretty quickly. But you won't have to ever solve anything like this complex. But our order is first knots. Our first is parentheses. So if we have anything in parentheses, we solve those first. Then we do knots, then ands, then ors. So let's break this down. We first start with simplifying our knots. So this becomes a false, and this becomes a true. Because true or true will always be true, and false will always be false. Because they're the same value. And if you keep going through that process, you would eventually get it to be false. And now it's a very important concept, which is short circuiting. Short circuiting pretty much is for ors or and statements. If it's an or statement, if you know your first value is true, the entire thing is true. Because as an or, if at least one is true, then it's true. And the same, it works the other way for ands. Because if one is false, then both are false. The entire statement is false. So try these two questions real quick. So our first statement says, we'll first simplify the not falses. So not false will become, I will write over here. Not false will become true. So this would become true. And this would become false. And false or false will always be false. And true and false will always be false. So it's false and false, or, now we check this one, false or true. And if it's true, it'll always be true. So it will be true. And true. True and true would be true. Or false would be true. And we see this is true for the same reasons as you go and simplify it. And this would also be a very simpler one, and it would be the same idea as you go false and trues and you simplify it throughout. Okay, so now we're on to 2.6. So we're halfway through Unit 2. So Unit 2 is comparing Boolean expressions. And we're going to learn about our friend called De Morgan, which is a very important law that you'll see again and again. And we're also going to learn also how to compare objects. So remember we said equals equals don't work. We're going to learn about dot equals now, this unit, or this topic. So we have something called a truth table. And pretty much you set it off with trues and trues, and you just do every combination. And the combinations are pretty much 2 to the number of variables you have. So if you want to do like A, B, and C, then it would be, you would do 2 to 3 or 8 rows. So you would have to add another few rows. But because there's 2 variables, it would be 2 to 2, so there's 4 rows. 1, 2, 3, and 4. And we do every combination. So we do true and true, true and false, false and true, or false and false. And the order doesn't matter. You can also start with false and false, false and true, true and false, and true and true. And then you just do each section one by one. So you would do A and B, not A and B, and then you would do the other side, not A and B. And you would go you would go through and you would just check each value. And then from there, this table shows us De Morgan's law, which pretty much is distributions of nots. And as you see, not A and B becomes not A or not B. And the same is for the other way around. Not A or B becomes not A and B. So pretty much you flip the values of the first two and you flip this sign to the opposite. Pretty much it's distribution of a negative one. And the second part is null and aliasing, or just dot equals. And if you remember, we said there's 2 cars that are the same box, and we looked at addresses. So aliasing is when you just say you define it as a different variable. So we say Ferrari 1 is equal to Ferrari 2. And this is true because we're saying the address is the same. We're saying this is equal to the memory address of this. And finally, we can use null, which is pretty much, it's a placeholder value. That means it has no memory. And dot equals is used to compare two methods. And so if we look back at our example over here, if you use dot equals, then these would be true. Because usually classes have a dot equals method to compare the variables of each method. So we'll do, let's see. We'll do the second one, because this is code-based. So consider these two following, consider this class, and what is the output? So we have thing 1 is equal to thing 3040, thing 2 is equal to new thing 2080, thing 3 is equal to 3040, thing 4 is equal to 1. So 1 dot equals 2. We're gonna check the dot equals method. My pen broke. Okay. I have to reload the page then. Not sure. But... So you first start with thing 1 equals 2. And as we see these numbers, we check the dot equals method and it says it's just comparing the values of foo and bar to each other, which means this would be false. Now we're checking 1 equals 3. And we said that it would be false always because it's not comparing the same number. But now it's saying 1 and 4, and this is aliasing or whatever, however you want to say it. This would be true because it's the same variable. We're saying thing 1 is 4. And then we use dot equals, which means these two things are true. So it would be false, 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 true. Which would be... Wait, this is true. Oops. This is true. So this would be B. And we got it right. And if you'd be interested in reading this explanation, you can find it on 5hive.org. Practice the other question as well. Alright, so now we're on to 2.7, which is while loops. And you will see these a lot in FRQs and MCQs, while and for loops. So these next two topics are really important for the next few units. Or next unit 4 especially, but... So, iteration is just repetition. And we have for and while loops, and it repeats some number of times from 0 to n. And you know when to stop when when it turns to false. And if it never turns to false, it's called an infinite loop. If it's false before it starts, it's never executes. And if it goes to the loop one or few times, it's called an off by 1 error. You will never see a call to one off by 1 error, but you will get that code error eventually. And this is a while loop, and it's pretty much while condition is true, do something. So quick example, we start with counter equals 0, we say 0 is less than 10, it's true. And then it's true again, because counter is never changing inside here. So it's again, and again, and again, it'll just keep printing this out, and eventually your thing will crash. And then if you put counter inside, now every time you go through, it goes 0, then it becomes 1. Now you check with 1, it's true, so it does it again. And it prints 10 times pretty much. So it'll print the thing 10 times. And for these solutions, you pretty much would write a number. If you want to print a number from the other side, and you would print all the digits, and starting from the last digit, so you would print 3 first. You would say while num is greater than 0. You would say you take the mod of it to get the remainder digit, divided by 10 to take out this digit, and then start again. You take the mod of this to get this number, take it out. Mod of this number, take it out. Mod of this number, take it out. Mod of this number, take it out. Then it would be 0, so the loop would cancel. And that's how you would do this. And you'll see this, it's come up on past FRQs, like in 2017, just putting numbers backwards. So it's a good method to know. 2.8 is for loops. And for loops are the same thing as while loops, but now you have a method. So the syntax is, there's 3 parts. You first have your int, so this is your starting value. You have your condition, which will be checked every loop. And then you have your iterator or increment, and it adds a number each time to get to your Boolean expression. So your initialization is, it's also called the loop control variable. And it only runs once, which is the first time you run it. And it's pretty much your counter variable from the while loops. Your Boolean expression is what you're comparing to. So you're just going to be checking this with this. So your LCV will be compared to your Boolean expression. And then finally, your incrementer updates your LCV to check with the incrementers. So they all work together to make sure your thing doesn't run infinitely. So if we were going to check how this code ran, you would see that first it starts at 5, goes to 9. So if we first run it, so that is 5 is less than 9. So we run the first time. So 5 becomes 6, and everything is awesome. This prints once. Now it's 6, so we're gonna say 6, and now we have to add 1 because we went through the loop. So now I is 7. Is 7 less than 9? It is. So now it prints again. But now this is 8, so now it only prints twice. And as you see, it prints twice. And remember how we did going through like 3, 7, 9, and we like print backwards? Now we're gonna do it with a for loop. And the way to do it with a for loop is pretty similar. You put your mod 10 inside, so you're just taking the last number, and then you're incrementing your every run through, you're dividing by 10. And you're saying it's greater than 0, and your first number is I is equal to null. And this would be your while loops. And then now we're on to 2.9, which is just implementing these, which is pretty much just saying do it with specific ideas. So maybe you compute a summer average, determine a max or min value, etc. So this is a really short article, this topic. So we would say write a method that takes some string and determines how many letters in the string are lexicographically smaller than the respective. So let's say ABS, your method should output 2. This is because when comparing A and B, A is indeed lexicographically smaller than B because B comes after A. Then with B and S, because S comes after B, B is lexicographically smaller than A. And lastly, we don't compare the last letter, which in this case S, because nothing comes after, so you should not take into consideration your method. Please try this on your own and then compare to the solution below. So I'll give like a minute or two to solve this. So Alright, hopefully that was enough time. Solution was this. Pretty much you start with a counter, then you're going to check the length of a string, -1, so you don't want to go over it. And then we're going to do some substring, and we're going to do a compare to method. And we're going to say I plus 1, so we're getting the first, we're going to get one string character, and compare it to not this string, but the next string, and we're checking if it's less than 0. We're using a compare to method on this entire thing. And if this is true, then we're saying counter plus 1. And at the end, we're returning counter to, which will give us our 2. So now we're on to 2.10, which pretty much is implementing string algorithms. And it was similar to last thing where we did a string, but now there's two main ones, which is find one or more substrings with a particular property. Maybe it's like it has a capital letter or something. But the ones we're doing today are determine the number of substrings that meet it and create a new string with the characters reversed. So our first practice is going to be a walkthrough one. So we're going to first determine the number of substrings that meet a specific criteria. So let's see apple. Apple will return 1 because it has 1 A, while purple will return 0 because it has 0 A's, because you're just checking the letter of A's that are present in a word. So now try on your own. Did you give it a try? Hope you did. This is for you. So we first have to start with the method, and we're returning an int, so it has to be, because we're returning an int to find how many numbers, and we have to take in a word because we're checking how many words are there. Then we're going to start with a counter, so int counter equals 0. And now we need a for loop. So we're going to add our for loop, and we're going to say it's the length of word, because we're just going to check each letter one by one by one. I'm going to say I++. And we should also put our return statements, and that's the easy part. But now the hard part, substring. And we want to check just one letter at a time, so we're going to do I, so our initial character, plus 1. And then we're going to check if it equals A. And then we're going to put an if, and then put our counter. And if you see this, it just does this. It starts an if, checks if it equals, and adds it. So if it was apple, it would say apple will be a length of 5. It would say from 0 to 1, which would be this first character, is equal to A. That's true. So counter is now equal to 1. Count is equal to 1. Now we're going to go to the next letter, which now we went through, I is equal to 1. So now this would become 1 and 2. This is false, so it doesn't do counter. And if you keep going, it would never update count again, so the count would just print out 1. Which matches our original question up here, which apple does print 1. So now let's try a palindrome. And if you've done coded chess before, you've probably done a question similar to this before. So a palindrome is a word that can be written the same forwards and backwards, and you're checking if it's true or false, and you're printing true or false. So, for example, passing in the word taco cat would yield true, because if you flipped it around, and race car would also print true, but this would print false. 5 would also print false. But on your own would print true, at least the abbreviation would. So, I'll give like, this is a harder one, so I'll give like around 3 minutes for this one. Okay, around 2 more minutes left. Hello to the new person who joined. And they're gone. I'll reveal the answer. So there's two solutions, which is the for loop solution and the while solution. The for loop solution pretty much is doing word.length minus 1, setting it I dot greater than equals 0, and then subtracting 1 for each letter. And pretty much that means we're going backwards. We're starting from the last letter and going forward. And we're just going to be going plus equals, and we're just adding each letter from the back to the front. So pretty much we're just, if it was like ABC, we're taking the C first, then the B, then the A, and this. And then at the end, we're checking if they're equal each other. In the while loop solution, we're doing a similar thing, but now we're just using a while loop to do that. And it's a similar idea, but now we're subtracting 1 at the end instead of inside the statement. And every for loop can be a while loop in CSA. There's usually a way to do both. So, FYI. Now we're on to 2.11, which is nested iteration, which pretty much means you're doing a loop inside a loop. So how many times does this run? This first section runs 7 times. The second section runs 5 times. So you multiply them together for a total of 35 times. And this would print 35 times pretty much. But it says a print line each time. So you're adding 5 hashtags in a row. You're going to a new line, and then you're doing that again for 7 times, or 6 more times. And it will look something like this after you did that. What's the output of this program? I'll give you around like 2 minutes to solve this. And hello to the 2 new people who joined the call. Alright, so let's try this. It says first I is going to be less than 9, and we're checking where j is less than or equal to I. So that this is going to look more like a pyramid, because you're going to get closer to I each time. So we start with 0 and 9, so that means the first one will have 9 of these in a row. Our next one will have 8 of them in a row. And we're going to be going adding each line. So it would look something like this, but it would be the other way around, because we start at 0, so it would start 0 to 0, and then 1 to 1, and it would so on. And here's a bonus question, you're doing it the other way around. So, hold up, I gotta erase the old stuff. So pretty much you're just adding dots, and it would look something like this. So it would be 2 statements, and it would look like this. And this is how you do a pyramid that goes the other way. You would start at 9, and then you would go backwards from 1. And you remove dots by just doing spaces. So now you're going to make a pyramid to do 2 of them. So I will give you around 2 to 3 minutes to solve this question. And there'll be a canonical solution at the end. So now it's been about a few minutes. Well, this is our canonical solution. It's a pretty long one. So first, you start with a for loop that goes through 9 levels of the pyramid. From there, you're going to first do spaces and adds to get this section of the pyramid. And then you're going to add spaces in between, and you're going to do adds again to get the other side of the pyramid. And as you see, they both go from J through I. And you add new lines at the end of each of them. So pretty much you're just going 1 line, 2 line, 3 line, 4 line, 5 line. And you're just going through each line one by one. And here's a bonus question. You're just going to be modifying the right stair one, the one that you did up, the one that you did over here, and you're just going to slightly change that. So you'll get like a minute or 2 for this, because it's a bonus. The answer for this is, it's very similar, it's just you remove 2 of the lines, so you're just removing this last line. And finally, 2.12, which is informal runtime analysis. And pretty much you're just checking how many times does this loop run, which we kind of did last time. So this time, it's first one runs 10 times, this one runs 5. It runs 50 times. For these 2 practice, and here's 2 practice questions. So for this one, it's going 2 to 21, so we're going to be running once at 2, once at 5, once at 8, once at 11, once at 14, 17, 20, and that's it. So it runs 7 times, and it runs 7 times, and then we're checking the second one, which goes 6, 13, 20, 27. So it prints 4 times. So 7 times 4 would be 28. Any questions? Questions? Okay. And this one's also pretty similar, but now there's an extra step. So this one goes 0 to 9. So this is this first, we'll go like pair by pair. So this first one will print, I will be 0, 0. The next one will be, now I will be 3. So now it will print 0, 1, 2, and 3. Now if we go to 6, so 6 will print 0, 1, 2, 3, 4, 5, and 6. And 9 will print 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if you add all these up, you would get you would get 22. And that's pretty much it. And if you see his explanation, it's a very similar explanation. You go from 1 to 4 to 7 to 10. AKA you're adding 3 each time. So that's the end of this Unit 2 lecture. So it would be greatly appreciated if you could fill the feedback form. And this will be uploaded on YouTube on 55org soon. So I hope you have a nice day, and that is the end of the lecture.